Why do some models of certain domestic compressor brands using R600a fail earlier than expected? Let's start by saying that compressors using R600a, also known as isobutane, offer many advantages. They are energy efficient, operate quietly, and run at lower pressures than other refrigerants. However, in practice, many technicians report that some R600a compressors from certain brands tend to have a shorter lifespan than those operating with traditional refrigerants like R134a or even the older R12. Below, I'll explain why some models from specific compressor brands tend to fail or wear out prematurely from a technical perspective based on real field evidence. 1. Very low refrigerant charge. High sensitivity to leaks. Thanks to the excellent thermodynamic properties of R600a, household systems require very small amounts of refrigerant, usually between 30 and 90 grams. This means that even a micro leak, however small, can drastically reduce system pressure. Under these conditions, the oil overheats, the compressor runs without proper lubricant return, and begins to operate dry, which accelerates wear on the piston, valves, or connecting rod, and may even damage the motor. 2. Lighter and cheaper compressors. To reduce costs and taking advantage of the lower working pressure of R600a, some manufacturers use compressors with thinner housings, smaller, lighter pistons, lower thermal tolerance. These compressors are more efficient, but also more fragile when facing common issues like refrigerant overcharge, voltage fluctuations, liquid slugging. 3. Air entry due to vacuum pressure and suction leaks. Since R600a systems often operate under negative pressure in the evaporator while running, the following can happen. If micro leaks are present, the system can draw in air and moisture from the surrounding environment. This mixture with the R600a and oil may oxidize metals and produce black or brown residues inside the system, causing premature compressor failure. 4. Oil return loss due to abnormally low pressure. In an R600a system, the lubricating oil, typically POE or alkyl benzene, partially mixes with the refrigerant and circulates through the system. The oil's ability to flow depends primarily on its viscosity. If temperature drops unexpectedly, viscosity decreases, and the oil resists movement. Since R600a's evaporator pressure is extremely low, any small pressure variation in the tubing or evaporator coil can have a large relative effect. This new, lower pressure significantly alters the R600a's operating temperature, reducing viscosity and impairing oil return to the compressor. 5. Misability between oil and refrigerant. Misability refers to the ability of two or more substances to fully mix and form a homogeneous solution. In refrigeration systems, it is crucial that oil and refrigerant are miscible to ensure proper lubrication and heat transfer. If the oil and refrigerant have very different densities, they are more likely to separate into distinct layers within the system, preventing the oil from returning to the compressor. Under normal pressure conditions, R600a dissolves well in oil, forming a homogeneous mixture that facilitates circulation. However, since R600a operates at extremely low suction side pressures, any abnormal pressure drop in the tubing or coil leads to a proportionally large drop in total pressure, drastically affecting operating pressure and mixture density. 6. Oil degradation from moisture or overheating. If proper vacuuming is not performed during installation or maintenance, or if the compressor runs under extreme conditions, the oil may oxidize, lose its lubricating properties, turn into black sludge. This sludge can clog the capillary tube or filter, overheat the compressor winding, and lead to severe failures. 7. Low-quality PDC relays in conventional R600a compressors. Because R600a is flammable, sealed PDC relays are required to prevent sparks. However, many of these relays are low quality or have short lifespans, deteriorating over time. As a result, the compressor fails to start properly, makes repeated attempts until the winding burns out, or trips thermal protection repeatedly. This shortens the compressor's lifespan, even if the system is correctly charged. Since many of the failures described above are linked to sensitivity to low suction pressure, to avoid this issue you can A. Avoid running the refrigerator nearly empty. B. Check that the unit does not produce frost or abnormal ice layers that could hinder heat exchange in the evaporator and reduce pressure. C. Keep the freezer clean to prevent airflow obstructions that could interfere with heat exchange. D. Do not block internal airflow with food placement. E. Ensure the refrigerator fan spins and circulates air normally.